All right, ladies and gentlemen, let's do this trigonometry review real quick. I am hopefully going to be able to share my whiteboard with you guys. And today what we did was we used calculators to to find trigonometric functions, and we also use the DMS and the DD measuring system to work with degrees, minutes, and seconds. So let's get straight into it. So we know our basic trigonometric functions. We have our sine, our cosine, our tangent, right? We have the sine we know is opposite over hypotenuse. So sine opposite over hypotenuse, which is the acronym or whatever, or the word is SOHCAHTOA, right? So, which is sine opposite over hypotenuse. We have ka, which is cosine, which is adjacent over hypotenuse, right? And this is where the ka sound comes from, me and my Spanish. If you're probably watching this in English and you're saying, what is that? And the toa part, which is opposite over adjacent. So toa, t or tangent, equals opposite over adjacent. Let me erase that equal sign that I wrote before the t so as to not cause any confusion. So we have the SOHCAHTOA, but we also have other functions such as cosecant, secant, and cotangent. Now we know that the cosecant is the opposite of the hypotenuse, but we're going to use the identity formulas. And we know that the cosecant is 1 over the sine. Okay, 1 over the sine. And we know that our secant is 1 over the cosine. Is 1 over the cosine. And our cotangent, which is 1 over the tangent, right? So these are our identity functions. And what we're going to do is we're going to use a calculator, specifically a scientific calculator, to find these trigonometric functions, because in our previous video, what we worked with was the trigonometric functions of special angles like 30, 60, and 45. But what happens when we don't have those angles? What happens when we have different angles, right? So if we look at our textbooks and we go to the first problem on page 37, or the first example on page 37. Let me get myself acclimated with the exercises real quick. Page 37, and I believe that was example 3, if I'm not mistaken. Let me see. Yes, example 3. And they're asking us to find the cosine of 30, the sine of 75, the tangent of 67. So let's start with the cosine. And our problem is actually asking us to use a calculator and to round it to 4 decimal places. Now, when we round, we have to take into account that we use our rules of rounding. So if I look at the cosine of 30 and I go into a calculator, and when you have your calculator, scientific calculator, there's a key that says cos. You can use your calculator on your phone, or you can use an app, or you can actually get a calculator. And you have a key that says sine, cosine, and tangent. So if I want to find the cosine of 30, I go to my calculator and I hit the cosine of 30. And let's see if I can turn on my camera for a second. I don't normally turn on my cameras. Let's see if I can start the camera. And here I am. So you go to your phone. I have this app called RealCalc, and I just kind of type in 30, and then I hit the cos key. And it says that my cosine is actually 0.8660. So I want to round it to 4 decimal places. So I know that I have 0.8660, and next to the 0 there's a 2. So I'm just going to round it off, and I'm going to say that the cosine of 30 is approximately, and where I seem to have, I heard. Okay, so I'm going to go ahead and turn off my camera now. I just wanted to show you guys what I was doing. So let's see if I can turn my camera off. If not, you're going to have to see my face for the rest of the video. Anyway, let me go ahead and turn off my camera. So if I look at the cosine of 30, I know that the cosine of 30 is approximately, and we use this symbol, which states approximate, approximately 0.8660. And that would be the answer. Now let's say we have to look for the cosine of 75, I believe is our other, yes, it's the sine of 75. So we have the sine of 75. And the sine of 75 degrees we're going to look for that in our calculator as well. And we're going to say the sine of 75 degrees. And that would be approximately, if we get the exact value, it's 0.96592. It's actually, the answer is 0.965925826. Now we want to round that off to 4 decimal places. So we look at the last digit, which is the 9, and next to the 9 I have a 2. So we simply round this off to 0. We say approximately 0.9659. 9659. And we'll leave it at that. The next one that we're looking for is actually the tangent of 67 degrees. So again, we're going to look for the tangent of 67 in our calculators, right? That's, you press the key that says tan. In some calculators, it depends on what kind of calculators you're using. You'll probably have to click the tan button first and then actually press the equal sign. In others, you just you type in 67 and press the 10 button and it'll automatically give you your answer. It just depends on what kind of a calculator you have. I don't know if that varies in cell phones as well, but I do know for a fact that some calculators it does. So when I find the tangent of 67, I get 2.355 or 2.3558. So 2.35 58, and after that last 8 I have a 5, so you can round this to 3859 because it's actually 2.35 58.5, and because the number next to the 8 is 5 or higher, I round that up and I say 2.3559 approximately is the tangent of 67 degrees. Now we have to find the secant of 52 degrees. Now for the secant, because there's not a button on the calculator, at least in my knowledge, that has the secant function, that means I have to use the inverse or the reciprocal function. So I know that secant of 52, I have to use one of the identity functions. I actually have to use this one right here that says that the secant is 1 over the cosine. So I simply say secant equals 1 over the cosine of 52. So what I'm going to do first is find the cosine of 52 in my calculators. And for this one, and it says round to the last 4 digits. What I want to do is I want to round my final answer to the last 4 digits. So what you're going to do is you're going to look for the cosine of 52, okay? So you're going to say secant of 52 equals 1 over, and I have to look for the cosine of 52 using a calculator. And I want to include the exact value because what I'm going to do is I'm just going to round my my final answer to 4 decimal places. So if I look for the cosine of 52, I'm going to say the cosine of 52 is 0. Let me see real quick. The cosine of 52 is 0.615. So that'd be 0.615 6 0.615661475 1. And again, this is the exact value I get in my calculator. 475. And what you're going to do after that is you're going to divide. So you're going to divide 1 over that number. So you're going to take your calculator, right? And you're going to say 1 divided by 0.615661475, and your answer is going to be 1.624269246, and that is a mouthful. So your answer is going to be approximately, because we're going to round that out to 4 digits, right? 1.6243, because it's actually 1.624269, but because I'm going to round it to 4 decimal places, and next to the 6 there's a 9, I simply round that up to approximately 1.6243. And that would be how you calculate the secant of 52 degrees using a calculator. So the secant of 52. And that would be it for this example. What we're going to do now is we're going to look at the DEDS and the DMS, or the DD, excuse me, and the DMS ways of expressing angles in minutes. So I'm actually going to go ahead and clear this up. And then we're going to first talk about that. Now, when we're working with this system, we'll say that 1, and usually 1 minute is represented kind of like, I call it an apostrophe. I don't know if it has a name for it itself, but we say 1 minute equals 60 or seconds. 1 hour. Usually when we talk about hour, we have this apostrophe, and we know that 1 hour is 60 minutes. Right? 60 minutes. And when we're working with seconds, and it's because maybe one rotation is actually, one full rotation is 360 degrees. So sometimes if you see 1 degrees, you think that it's a really small number, but in reality it isn't. And we have this measurement to determine, we use this MS and this DD method when we're working with, for example, satellite calibration in space, or when we're working with determining certain parts of the Earth's rotation. So they're used for very specific examples. When we're working with seconds, we'll say 1, and it's usually represented with 2 apostrophes. And that's actually equal to about 3,000. So 1 hour has about 3,600 seconds. So sometimes we'll say that this is the same thing as saying 1 over 3,600. Now we can add and subtract them, and that's what we're going to do in a minute. And I'll show you on page 38 of your textbooks. Specifically, example number 3 and 4, or 4 and 5, which is what we're going to look at. Example 4 and 5. And in example 4 and 5, we're going to add these two, or we're going to add measurements. And let me read real quick about the method. And I'm reading from your book. It says, there are 2 traditional ways of representing part of a degree: degrees, minutes, and seconds. And that's called the DMS, and decimal degrees, which is DD. Most calculators allow you to enter angles in either DD, decimal degree, or DMS, degrees, minutes, seconds, format. And some even make the conversion between them. It says, however, we will illustrate a manual conversion technique. And we're talking about the degrees, minutes, seconds. Way of breaking down the degrees is similar to how we break down time in hours, minutes, and seconds. It says there are 60 minutes in an hour and 60 seconds in a minute, which result in an hour being broken down into 3,600 seconds. Similarly, we can think of a degree like hours. We can divide 1 degree into 60 equal parts. Each part is called a minute and is denoted as 1 apostrophe. 1 minute is therefore 1/60th of a degree. We can then break down each minute into 60 seconds. Therefore, 1 second denoted is 1 double apostrophe 1/60th of a minute, or 1/3,600 degrees. Okay, so we can say that this is right here. This would represent hour, and we can say 1 hour is equal to 1/60th of a minute, or seconds, which is 1,300, or 1 over 3,600 of a degree. And it says, and you would represent it in words like saying 22 degrees, 5 minutes, if we're using the DD method, or 49 degrees, 21 minutes, and 17 seconds. And we have kind of a little bit of a story problem here. And it says, we add and subtract fractional values in DMS from form similar to how we add and subtract time. For example, if Carol and Donna both run the Boston Marathon, and Carol crosses the finish line in 5 hours and 42 minutes and 10 seconds, and Donna crosses the finish line in 6 hours, 55 minutes, and 22 seconds, how much time elapsed between the 2 women crossing the finish line? The answer is 1 hour and 13 minutes and 12 seconds. We combine hours with hours, minutes with minutes, and seconds with seconds. Now, that sounds like a mouthful, but let's look at example number 4. In example number 4, it says, add 27 degrees, and I'm just going to write it in vertical form, but it says add 27 degrees ,5 minutes, and 17 seconds. And we're going to add that to 35 degrees, 17 minutes, and 52 seconds. 35 degrees, 35 degrees, 17 minutes and 52 seconds. 17 minutes and 52 seconds. So basically, the first step is to just kind of pair them up, degrees with degrees, minutes with minutes, and seconds with seconds, and then just add them. So 27 plus 35 is 62. 5 plus 17 is 22 minutes. And if I add 57 or 17 plus 52, I get 69 seconds. Now, the problem is 1 minute has 60 seconds. So if we say 69 seconds, in reality, what we're saying is 1 minute and 9 seconds. So what I have to do is actually add this 1 minute right here. Add this 1 minute to 22. So what I'm actually going to do, or my final answer, is going to be 62 degrees 22 minutes, or 23, excuse me, 23 because I add 22 plus the minute that I have here in 69 seconds, and that would be 23 minutes and 9 seconds. "62 degrees, 23 minutes, and 9 seconds." And it's pretty easy. In reality, it is nothing out of the ordinary. And if we look at example number 5 says subtract 15 degrees and 28 minutes. So we're going to subtract, this is example 5, the one I'm going to do now, 15 degrees, 29 and 28 minutes, excuse me. And I'm going to subtract that minus 90 degrees. Notice how the 90 degrees has no seconds or minutes. It's just 90 degrees. So what we want to do is we want to combine 90 with 90. So we'll say 90 degrees with 90 degrees minus 15 degrees and 28 minutes. So how do we go about subtracting the 28? I can't say 0 minus 28 because that would give me a negative expression, and time cannot be negative. So that's not an option. So what I need to do is actually do what I would do in a normal subtraction, and I would have to say, first thing I'm going to do is just to kind of illustrate, I'm going to say 0 minutes. Right? There's a 0 there. So what I need to do is actually what I would do in a normal subtraction. I'm going to borrow from the 90, and I'm going to turn that into 89 degrees. And since I borrowed the 0 borrowed. What did I borrow? I borrowed 1 second. So I borrowed from the 90 degrees, or I borrowed an hour from the 90 degrees is what I meant to say. And if I borrowed an hour from the 90 degrees, that means I have 60 minutes. So now instead of saying 0, I borrowed an hour, and 1 hour has 60 minutes. So I turn that into 60. And now I can just subtract that from 15 degrees and 28 minutes. And this is very simple. So 15 degrees and 28 minutes. "15 degrees and 28 minutes. 15 degrees and 28 minutes. 15 degrees and 28 minutes. So give me 1 second here. 15 degrees and 28 minutes. I'm sorry, I keep repeating myself. I just want to make sure that I don't lose track. 15 degrees and 28 minutes. So again, 60 minus 28 is 32. 60 minus 38 is 32. And 89 minus 15 is 74. So 60 minus 28 is 32. And then 89 minus 15 is 74. And this would be 74 degrees and 32 minutes. And that's pretty much how you do it, guys. So that is today's class. We will see each other in our next class. So until then, stay safe and enjoy the rest of your day. Bye.